Good. Donna, did you get that file? Okay. Adventures with Zoom. Because we have like 4 different accounts that set up into all the Zoom meetings, and the computer gets confused as to which one it wants, and then it gets to be a pain. Oh. All right, Donna, you're muted.
Are you able to make me a co-host so that I can share my screen?
Yep, I'm in the process.
I feel you. Zoom is fun.
I'm gonna wait a minute and then I'll introduce you.
It's only
Okay.
just now 9:27, Donna, so we might want to wait a couple minutes just so
Oh.
everyone has a chance to get in.
Okay, very good.
And we do want to be respectful of time because I know Karen has another meeting at 10:30.
I know, busy day.
Busy day. But one of the great things about doing the meeting virtually is we've been able to have presenters from all over the country, which is really nice.
Yeah, that's definitely one of the nice things. I guess the silver lining of this past year is like we've been able to connect with teachers that I normally would never be able to visit or see.
No, it's great because we've had some, our keynote speaker was from Nashville, and our other keynote speakers in Wisconsin, and it's just been great. We've had we had someone from Calgary yesterday for one presentation. Lots of good things.
Yeah, that was very interesting, and what the students did.
Yes, it was.
Raise awareness.
Mm-hmm.
I absolutely agree, but it was kind of overwhelming. That was a lot.
Well, that's the big thing with, right, to do project-based learning well. It's a big undertaking. And it sounds like they really thought through it, and they also had a lot of time in how they chose to do it, which was really.
They had a separate person to do the instructional director. I mean, it was 2 people working together for each.
Right.
You didn't have to do it by yourself.
I think that's really important. Yeah.
And they didn't have a huge student overload.
Right.
That's a big difference.
Oh.
Okay, it looks like it's 9:30.
Yeah.
So I'm gonna start.
Right.
Good morning. I'd like to introduce Karen Yi. She is a curriculum and professional development specialist at the Illinois Mathematics and Science Academy and has been involved in science education since 2010. Karen attended the University of Michigan and earned a bachelor's degree in neuroscience. While in college, she developed a passion for ballroom dance as a member of the UM ballroom dance team. Through the team, Karen competed for multiple national collegiate titles and also led outreach efforts teaching dance to high school and college students and local community members. Karen also enjoyed these teaching experiences that she went on to intern as a teacher at Breakthrough Santa Fe and eventually earned her master's in education at Hunter College in New York City. In addition to teaching in New York City, Karen also taught in Charlottesville, Virginia for 5 years before transitioning to her current role at IMSA. Karen believes that teaching science should be fun and hands-on as learning ballroom dance. She enjoys finding creative ways to teach abstract concepts and provide students with inquiry-based learning experiences. Karen has taught different levels of chemistry, including AP and biology, and has facilitated various professional learning workshops related to K through 12 STEM.
All right, thank you, Donna. Good morning, everybody, and welcome to A Unified Science. My name is Karen, and I'm very excited to be here with you all today. As mentioned, I currently work at the Illinois Mathematics and Science Academy, though I did teach Regents chemistry when I was in New York, so shout out to any New York teachers who might be in the room. The objectives for today's presentation are to explore integrative models as they relate to content and skill standards, to reflect on how to engage students in real-world applications of scientific concepts, and to identify and adapt integrative techniques to your individual curricula and classroom environments. All right, so what do we mean by integrative? So here's a definition that we use at IMSA. Integrative learning experiences are those which forge meaningful connections of concepts, constructs, and principles within and across academic subjects and real-world situations. So why is this important? So I'm going to start by briefly talking about the difference between instrumental and relational understanding, which was outlined in a dated but still very relevant article by Richard Skemp. So I want you to consider, how might you learn to navigate a new town or a new city? All right. Well, you might start by just learning several fixed routes to get from point A to point B, whether it's your home to school, house to the grocery store, etc. And these fixed routes are an example of instrumental understanding. The other option is you might explore and just kind of learn your way around. And if you do it this way, you build what is known as relational understanding, because now you have built a mental map or a cognitive map of the entire city. All right. So you can learn about where everything is located in the city both ways. So what's the big difference? Well, if all you know are fixed plans, then you only know directions based on a very specific set of starting and endpoints. So if you make a mistake, then you kind of get lost, and you're going to stay lost unless you can retrace your steps and go back to where that point A is in your mind, right? But if you have an entire mental map of the city, you know infinite ways to get around from one place to another. And so if you get lost, it's not that big of a deal, and you can recover more easily because you have an idea where everything is related to each other. I know I have suffered from this recently. Anytime there's construction in the summertime, Google Maps is telling me to go one way, and then all of a sudden I'm like, I don't know where to go, right? So this analogy is also relevant to STEM education in that, unfortunately, due to standardized testing, I know that I have felt like I teach my students a lot of kind of high yield fixed plans in order to make sure that they pass the state exam, right? And as a result, students don't always know how all the concepts are connected to each other. And so if they make a mistake from step 1 to step 2, you know, they're not going to get the answer correct. Or we can also see this when you're teaching converting from grams to moles, and then all of a sudden when you flip it, teaching from moles to grams, they don't realize how to apply that, even though it's the same concept. Okay. So what we're going to do briefly, I'm going to put everyone, or maybe someone else will, I think I can do it, everybody in breakout rooms and have you guys engage in a card sort activity to kind of take a look at, just explore inquiry and also instrumental and relational understanding. So what I did, let's see how many people are in the room. We have 25. Okay. What I did is I have pre-set up some bit.ly links. So it's just bit.ly/NEACT WD for Wednesday, because today's Wednesday, sort, and then followed by the breakout room that you end up in. What is the easiest way for me to open breakout rooms right now? You're muted, sorry.
Sorry, what if we posted the links in the chat and people can just pick?
I can definitely post a link in there, but I feel like I need to open breakout rooms first, right?
Oh, hold on. Let me think about that. Because
I think I can do it from my end.
Because we have breakout rooms literally within Zoom.
Mm-hmm.
And then, but we need to have we need to know who's in what room. Yes?
Yeah, it looks like I can assign them automatically if that's okay.
Yes.
All right, so what I'll do so that everybody has it. So I'm just gonna post the generic bit.ly/any ACT Wednesday sort, and then whatever room you get sorted into, you're just gonna have to replace that number with the breakout room. So if you're breakout room 1, replace that number /# symbol with the number 1. You will see a Google Slides link when you open it up. I'll keep the room open for 10 minutes, but it's a pretty brief sorting exercise. All right, so go ahead and copy that link. I'm gonna open some rooms. And it looks like it's set for 10 minutes, although I'll give you guys some wiggle room if we have tech issues. So here we go.
All right. I'll jump into one of the rooms too, Karen.
Okay, yep, I'm gonna kind of hop back and forth.
Okay. All right. It looks like everybody's in, so I'll go join a room.
Carol, if you're just joining us, I just put people into breakout rooms to do a quick activity. So I'm going to throw you in room 1, if that's okay.
Okay, great. Thank you.
All right, you should get an invitation. Hi, Rebecca. Are you just joining us?
Yeah, sorry, I'm on the West Coast, so.
Oh, I feel you. We are in the middle of a breakout room activity. I can throw you in a room real quick.
Yeah,
Just to...
could you send me to the, sorry, I'm looking at it, the inquiry-based activities?
So you're looking for a unified science, right?
Yes, a unified science.
Yeah. Okay. So we're in the middle of doing like a inquiry card sort activity right now. I can just throw you in a breakout room so you can see it. I'm going to put you in room 4, and then let me see if I can chat it to you. I just made bit.ly links for everybody. So do you see the chat message?
I do.
Okay. And then I'm going to throw you in room 4 and you should be able to see everything.
Awesome. Thank you so much.
Yeah. Room 4. All right, I think we're all back. Thank you for entertaining me, and definitely not a chemistry card sort. But there's a couple of things that I want to point out about it, and I do appreciate everyone's patience in working with the virtual format. I was telling one group it's a lot easier when you can just like rip the pages and stick them all around the table and work with it with your hands. It's not as fun to try to drag it on a screen, especially when multiple people are working on it at once. All right.
And I would like to apologize to group 3 because I was talking to group 5 and I had opened group 3 and I kept moving their stuff. And I was like, why do you guys keep moving this? And they're like, we're not.
Oh, Zoom fun. All right. So I'm just gonna display an example from one group's, but I think it's safe to say, just by looking at everybody's, that once you found February, you could probably base everything off of that. I also heard some groups try to find days that had 31 versus 30 first, and then just kind of what day of the month it started on. But the gold one or the yellow one was kind of the easiest one to identify once you found it, just because February is the only one that has 28 or 29 days, right? And then you kind of just had to build off of it and make sure that everything matched up afterwards. So this is just one example. I can't remember which group this is, but thank you for trying to label January, May, September, December on there. All right. Now I know this isn't fair because again, on the Google slide template, you're kind of restricted to a certain space if you don't want to zoom out or zoom in so much. But here's another way. I know the colors aren't exactly the same, but here's another way you could organize these cards, right? Now, if I draw, and it's supposed to be a circular shape, right? So now my question to you is, what does this remind you of?
A clock.
The clock.
A clock, yes. And I have a little animation to go with it, right? It looks like a clock, right? Now, if you sort it this way, there's a lot of different relationships that you can now draw between a clock and a calendar, right? The most obvious being that the numbers on a clock correspond to which month of the year it is, right? The graphic that I superimposed on here, you can also see how the year is split into quarters, right? So you can assign months to specific seasons and divide the year into 4 seasons. You could also talk about scaling. So we know there are little tick marks in between each number, right? So the second tick marks between each number, right? If you were to translate that into a calendar, it represent what days of the month, right? So there would be 31 tick marks between 12 and 1 if you're looking at it like a calendar, right? And showing it this way just makes it seem more cyclical, right? The year repeats itself, starts in January every year, right? So when I first saw this, right, I was like, wow, like I look at a clock and a calendar every day and I never would think to sort it this way. But all these relationships that I didn't really think about came out when I saw this. So I wanted to bring this up, one, because it's a easy to use activity no matter what content you teach, but it's a nice example of how just any single lens approach can really limit people from making connections, right? And so integrative learning experiences, the idea behind them is to just get you to increase your relational understanding, right? Knowing how everything is connected, which helps you better retain that information and then apply it across other areas. And ultimately, I don't know about everybody else in here, but like, I never assumed that most of my students were going to go on to become chemists. And so I wanted to instill them with critical thinking and problem solving skills, which would be useful no matter what they ended up going into, right? So now in the small amount of time that we have left, right, I think we can all understand like, okay, yeah, this is important, but like, you know, I taught 45-minute periods when I taught in New York. I've also taught 55 minutes, block schedule, assembly schedule, right? There's all these different things. And now you're like, okay, now you want me to do integrative learning. How am I going to fit all this in, right? So I'm going to start by just saying, like, let's take a look at the different tiers of integrative learning. I know that anytime I've gone to BD and I really buy into whether it's problem-based learning, inquiry, what have you, but it just seems like so much to take on at once, right? It's like, I really like this idea. I don't have time to write this curriculum, right? So let's start from the bottom, right? The easiest way, the simplest way you can incorporate some sort of integrative learning experience into your curriculum is simply by including an example or an application problem. That could be a homework or an extension problem, classwork, just to show that it applies to something outside of chemistry class, right? The next level would be to do a fully integrative one lesson, one activity, one lab, one project, right? So one single period, whatever that may look like, 45 minutes, 60 minutes, 90 minutes. I know we teach a variety of schedules. The next step up would be to link together a series of lessons or an integrative unit, right? The ultimate level is to teach a fully integrated course. I know I've seen some schools do integrated chemistry and physics, integrated biology and chemistry. However, this is a lot, right? And ultimately, it requires a lot of dedicated and coordinated planning at your own school, both vertical and horizontal planning, and also people who have the time to put together a curriculum, right? And so for me, teaching a fully integrated course just never seemed like it was a practical option. And so I'm just kind of talk about what are some ways that we can focus on the first three tiers, right? Whether it's just one example or whether it's a full integrative lesson or multiple lessons that we could do. All right. So first, I'm just going to highlight some common high school introductory chemistry topics, and then what are some applications that you could do with it, right? So for dimensional analysis, with a lot of my students, I will bring in a medicinal dosing kind of question. So if it's a dose that is this many milligrams of medicine per kilogram of body weight, or you need to administer an IV fluid at this many drops per hour, stuff like that, and having them calculate essentially how much medicine they need to give to somebody. Gas laws, a common tie-in is the respiratory system, and also scuba diving. Solutions, concentration, and molarity. It lends itself well to talking about tonicity, osmosis, water safety. Colligative properties, specifically freezing point depression, is a nice way to kind of talk about the environmental impact of road salt. I think, especially with you guys being in New England and me in Illinois, we definitely salt our roads a lot every winter. Molecular shapes, polarity, intermolecular forces. You could definitely talk about soaps or just general solvent efficacy on various dyes or stains. And then electrochemistry, I will admit, was my Achilles heel when I taught AP. I worked with a physics teacher to talk about circuits and also how to connect things in series. And we kind of worked together with our AP Physics 1 and AP Chem classes on that one. All right, so I'm going to give you some specific ways you could work these into a full lesson or activity. First one, using current events, case studies, or a local news story is a really great way to have students look at how what they're learning in class has to do with what is going on in the real world, right? Or answering our favorite question, when are we ever going to use this, right? So here's a story from 2013. It is just around when the Nintendo Wii came out, and a radio station had a Hold Your Wii for a Wii contest. Where contestants basically had to drink as much water as possible without peeing, and then whoever lasted the longest would win a brand new Nintendo Wii, which I think was $200 at the time. And unfortunately, a 28-year-old woman ended up dying. All right, so news story you can pull out, bring it to your students. I use this story when I teach about solutions of molarity, right? We talk about why IV fluids aren't just pure water. And then I have students do a modified version of the classic gummy bear lab, where they essentially create solutions of various concentrations, sugar and salt, and soak them overnight to see what happens to them. And here's one of just the top left, the one with no liquid is just the normal gummy bear. The over engorged one, it was soaked in pure water, and then going clockwise, it's just it's increasing concentrations of sugar in this photo, right? So students use their observations along with just calculating molar mass of water, sugar, any other solute solution you want to give them, right? To talk about how water is a substance that is small enough to move, essentially pass into or out of the gummy bear membrane, if you want to call it that. And then they use this as an explanation, to construct an explanation for what happened to this woman in the radio contest. For students who've taken biology first, they've done a similar lab before. I know I've done it with potato cells, onion cells. So it's a nice way for them to apply this concept again. And then for students who haven't, the way that it's set up, it's still kind of an inquiry-based gather observations, defend your answer. So it allows them to still make the connection between solution concentration and osmosis. I have a chat question, I think. Awesome, I'm glad. Yeah, it's a fun one. And it always, like, even if they've seen it before, it always grosses them out just how much sugar you have to dissolve for that gummy bear to not change in size. All right, next. If you structure the integrative lesson, activity, lab, whatever you want to call it, as an inquiry or problem-centered learning experience, it definitely takes a lot of pressure off of you as the teacher, because you're putting the responsibility on the student for making observations and making sense of their data or their evidence, and then apply that knowledge to other situations. So one example, I, like probably many of you, like to use PhET simulations, and the gas behavior one has finally been updated to be HTML5 friendly, right? So I usually start the unit by having students work in pairs and use the PhET simulation to deduce relationships between pressure, volume, temperature, and then cite specific examples, whether they want to draw it or they want to explain it in writing something from the simulation that helps back up their answer, right? To show them how this applies to real life, because we can't see gas particles, I have students build a model lung, and then they try to relate the particle nature of gases that they observed in the PhET simulation to what they observe happening with the model lung, right? I also pose questions about scuba diving, pneumothorax. I try to simulate that by asking them what happens if you puncture the plastic bottle, right? While your balloon still inflate. And just have them explain what is going on in terms of particles, pressure, and volume. I've done this first as a collaborative unit with the anatomy teacher at my former school, but I've also just done it in isolation within my own chemistry classes. And it's definitely gone well both ways. And it's nice to kind of see, to kind of relate the particle simulation to something more tangible and something that they are doing on a daily basis, breathing, right? And again, I know this is a more bio-based topic. Even if they haven't taken biology, just seeing that physical model kind of allows them to make the connection between gas particle behavior and respiration. One way, for those of you who like to plan out on paper, if you want to help visualize how you might build an integrative learning experience, is by making something that I'm just going to call a topic wheel. It's a nice way to plan an integrative lesson or unit for your own class or potentially with another teacher. Essentially, to set it up, put your subject and a topic that you teach in the middle, and then you're going to branch off bubbles from it that have to do with other content areas, right? And essentially just trying to brainstorm what are potential tie-ins that you could have. So in this example, I'm starting with chemistry and Boyle's law. I put the equation there. And then here are just a couple of ways that they apply to other areas. So some of the ones that I showed you already, the respiratory system, breathing pressurized air, discomfort you might experience during flying, scuba diving, and math, it's definitely exploring an inverse relationship. In chemistry, in physics, kinetic energy, elastic collisions. If you wanted to explore a more social studies based topic, you could talk about how does something become a theory versus a law, since it's called Boyle's law. And then in terms of English skills, I think the easiest thing we can build into a science classroom is the claim evidence reasoning structure, right? So supporting your argument with evidence that you've collected, either in your own experiment or in a simulation. All right. Okay. For those of you whose schools use Danielson and need to submit artifacts as part of the evaluation process, I know everyone's favorite thing, components of both integrative and inquiry-based learning experiences can be found in all 4 domains. I tried to highlight the ones where you can find the explicit wording for it. Elements for integrative or interdisciplinary learning are listed in the details for domain 1. And in addition, because integrative and inquiry-based learning involves more active participation and critical thinking from the students, you'll find these elements in domains 2 and 3. And I'm going to check the chat before moving on. Yes, Deflategate is another good one. I've used the case studies that was released for Deflategate as well. And every year students accuse me of just hating on the Patriots. But I tell them I'm not looking for a correct answer based on a team that I may or may not like. They need to use science to defend their answer. But yeah, that's another good one because we've definitely heard it.
Especially because we're in New England and
right.
Oh my God, Tom Brady is God.
Yeah.
I always start off by saying, I'm going to challenge you to, whether or not you think that the Patriots did it or not. And even after I show them I think even after I show them that, I have them do it. Like we look up all the numbers and stuff like that. And, and I say, okay, even like using like the lowest possible pressure that the football could have been going into the game and And, even some of them are still reluctant to believe it. They're like, no, Mrs. Lerner, it's not that way. I'm like, well, the science doesn't lie, So yeah, that's always a good one. I love that.
No, for sure. Yeah, it's I've definitely done it for the last few years as well. All right. Yes, I will post. So I will post a PDF. I think there's a shared drive that's supposed to go under, so I can definitely share this.
Or you can email it and I can upload it, whatever makes sense for you, Karen.
Okay, awesome. All right. One more chat before I move on. Oh, thank you. All right. So let me click back. All right, some final thoughts on incorporating integrative learning into your classroom, right? Like with anything that I feel like, having taught anywhere between 1 to 5 preps, right? I totally understand how busy we all can be. So I kind of want to make this as least intimidating and as accessible as possible. So start by just making small changes to lessons that you already use, right? Again, if it's just throwing in a medicinal dosing application question in the classwork when you're doing, practice with dimensional analysis, just start doing that. If you don't want to do the model lung activity as a whole, but you just want to write that into a word problem, right? Like just having them see how that applies. You can just start there and then do your normal lesson that you normally would, right? The other thing to keep in mind is that I think when we hear interdisciplinary or integrative, I know for me, it's like we were worried about like, how do you want me to teach history and chemistry at the same time? Or how do you want me to teach this and chemistry at the same time? And I just want to point out that you don't need to split your time equally between each discipline, right? I know, at least I'm just going to talk about the Regents content, but like, I know I was pressured to be able to fit in the entire scope and sequence into a school year, right? So we're still responsible for teaching that. And so I know time is limited in terms of how do you give students some more interdisciplinary connections. And again, to do that, you don't need to just carve out all this time on Regents Chem and dedicate it to something else, right? It can be small. The other thing I want to point out is that integrative and inquiry-based activities are largely still structured, at least mine are, and I still have students follow a guided procedure because again, when you teach 45-minute class periods, every minute counts, right? And so I just want to point that out, and that just because you're giving them an integrative or an inquiry-based activity doesn't mean that you give them one objective and then they figure it out, right? You can still set it up so that they're following a series of steps, but just kind of focusing it on having them make observations and figure out what that means, right? I would say that a truly open-ended, student-driven investigation is really only appropriate for students that are doing like a semester-long independent study or research project. But for those of us that are trying to fit it into our tight schedules, it's totally fine if they're following a guided procedure, as long as you are focusing on having them make meaning of what they are observing in front of them. And finally, I do want to just point out that, we've been talking about how do we have students draw connections between different things and form relational understanding. But that doesn't mean that instrumental understanding is absolutely useless or not important, right? Like there are definitely certain concepts, vocabulary that they're going to have to memorize before students can apply it, right? Like if you don't know what the definition of molar mass is, right? Like there's not a lot of application you can do with that. So I just want to point out that it's okay to still have students want to memorize certain definitions, vocabulary, especially if it's stuff that they can't easily look up on a reference table, the periodic table. There is definitely still value in having access to that information before they can apply it. All right.
Mhm.
And so I will leave you with the question, what does chemistry have to do with blank? Right? And just kind of hopefully inspire you all in whatever way is most practical for you guys to kind of just show students that chemistry is all around them and how it applies to their real life. I will definitely include this in the presentation slides, but I did include the links if you want to read more about relational and instrumental understanding. I have the original link for the calendar sorting activity, if you would like that, the PhET gas properties link, and also the Danielson diagram if you guys are interested. And that is it that I have for you guys, and I will definitely take questions. Here at IMSA, we definitely want to hear feedback, whether we're presenting internally or externally. So I'll definitely drop this link in the chat as well. But if there's any feedback you'd like to provide, it's a quick Google form. Definitely would really appreciate it. We also host various professional development opportunities and events. Some are chem related, but definitely a variety in K-12 STEM. So definitely check us out. And then if there's something, I know I was talking with some of you guys earlier, the silver lining of Zoom is that we've been able to work with educators kind of all across the country. So if there's something that you guys want to collaborate on or have us work with a school, we can definitely work something out. Feel free to contact me if there's something that you think would be interested in setting up. And yeah, I will leave it at that. And I'm going to check the chat and take questions.
I was just updating the page for the that we have that links all the information on too, so we can put that there.
I'm just
I
trying to
just
catch up
love
on the
thinking about
chats.
connections.
Yeah, I think, and I hope that the examples of content you could integrate are meaningful. Those are the ones that I found were the easiest to kind of build in every year and not take too much time away from, everything else that they're expected to learn. So, yeah.
There are a lot of biology connections you can bring in too, but you do have to take time to think about them.
Yeah. And, I've been blessed with having good coworkers. Like I said, electrochemistry was my Achilles heel when I taught AP Physics, and Andrea sat down with me after school like several days a week when we just built galvanic cells. We tried different things. We tried different wires, and we tried to, it was a fun experience for her too, because it's, they use breadboards whenever they build circuits. So for her to see it deconstructed and for me to have a better understanding of how it all worked, that was definitely fun. And we had a health sciences academy at my school in Virginia. And so that's why I was able to work with some of the teachers to kind of figure out some more health and biology connections as well. But
right, because the kids really relate to that.
Right.
And
especially because a lot of students who are interested in pre-health or pre-medicine, they view chemistry as just a must-take course, and they don't really see why it's important. And so to kind of be able to show them why it is important and not just a torture class that the curriculum requires out of them. So
right.
I taught a full year integrated science course where we integrated all 4 biology, chemistry, physics, and earth science actually all together.
Wow.
And writing it was very challenging, but and we ended up dropping it because it was just too hard to cover the different things that needed to be covered and whatever. But it was really fun. It was really fun because we ended up teaching it by big themes, like health, and then how all the different subjects related to health, or we had a theme of materials, and then how all the different things related to materials. And it was really fun, actually.
Yeah.
That's the way international baccalaureate classes are taught. They have 7 years going through junior high and high school, and they teach all of the sciences together. That's how my nephews learned it. And they throw in a lot of math as well. But it's all done for them. Like, you don't have to develop the curriculum. They give it to you.
And right. I think what happened, the reason why our class ended up falling apart was because it was a one and done. And so what happened is that the kids who took that course then went on and took biology, and then they didn't have enough chemistry from the course, from the integrated class, to be able to go in to take AP chemistry. So that if they wanted to take AP chemistry, they had to take regular chemistry, but then they couldn't have a chance to do physics. And so most kids ended up feeling that by taking that integrated course, it was as if they lost a year of science. They still ended up having to take all the other sciences anyway. Whereas I think with the baccalaureate, you kind of, if it's for 7 years, you get all the sciences because you have a little bit of everyone every year.
But it would be a great elective for those students who do not aspire to go into higher level earning or can't see themselves there. So it gives them a smattering to application. So it would be a great elective.
Yeah, it was a freshman course, and maybe it would be better as a older level course for the kids who are like, I need one more science class and I'm sort of done. And just having a sort of a smattering. But it's gone now, partly because of NGSS requirements. They kind of we sort of need to fit in other things instead.
I work a lot with my biology teachers, AP Bio, regular bio, in terms of intermolecular forces, amino acid structure, and protein synthesis. So it kind of helps them. The students who take the EEP Chem with me build models, sometimes styrofoam ones, themselves, and get the bond angles correctly so they know how to align everything up.
Right.
So it was a great hands-on project. They liked it. The biology teacher liked it. It was fun. But I see in my mind the integration between biology and chemistry.
Right.
I know this integration with physics, with pressure, with force, F equal ma, and yada, yada, yada. But I tend to lean towards the biology end.
Yeah.
And I've also
I basically was a biochem major, so I'm with you that the bio connections come a little bit more naturally.
I also go over the chemistry of stain removal with my students. Great.
Yeah, we can talk about like permanent versus non-permanent, what that actually means. And I know like for them seeing that like acetone or strong rubbing alcohol concentrations can get rid of a permanent marker stain, like it blows their mind. I still tell them, please don't write impermanent marker on my board. But
I had a student work with me one year in the second year, and we did like versus unlike in the ability to dissolve. And she literally chewed a piece of gum, stuck it in her hair.
Wow.
And then she chose to use olive oil and rubbed it into the gum and then dissolved it and pulled it right out of her hair. So, which I thought was really brave.
Yeah, for sure. But I think I was talking to a colleague because we were looking at how to do some like hands-on STEM at home activities and trying to provide some focus questions to give students. And one of my favorite labs with biology is the strawberry DNA. Just take your anger out on smashing a strawberry, right? And it wasn't until she and I were talking about how to write some of the integrative focus questions that I realized how much biology and chemistry were in it. Like I've always done it as a, biology activity because you're extracting the DNA from a strawberry. But then you're like, whoa, why are we using soap to dissolve the cell membrane? What is the cell membrane made out of, right? And then, I realized that in biology, when you talk about the cell membrane, you use the word hydrophobic, hydrophilic, and those are the only things you ever talk about. But then it's like, wait, like this has to do with polarity. This has to do with intermolecular forces and solubility, and then so that's definitely a fun one to do as well.
Then you got your surfactants.
Right.
Okay. Anionic, cationic, and then, the place in between and what happens. It's kind of exciting stuff. I like the one with the gummy bear. I mean, you could almost do that at home. Parents can actually see their kids doing that one at home and then trying to work through it. And it was I thought that's a real good way to do that. And understanding solution chemistry in our body.
Right.
And understanding the impact to one's kidney.
Yes.
Okay. And then once the kidneys have its impact, the liver has its impact. And in terms of toxicity, I don't think students understand the notion of toxicity. And well, that's a poison. I said, everything can be toxic, even water.
Right.
It just sets our
all
whole
dosage.
Our whole, homeostasis just gone. The whole thing. It just is amazing. And then I last year, something about calcium. Okay. A friend of mine lost his husband to ALS. And they had him taking extra doses of magnesium to help with the pain. And then they had him on calcium. And then I went in and checked, and it's OMG, calcium, magnesium, activity, replacement. And then I got it. It just stuck, you know? And I'm like, wow, you learn from a life example. And I thought that was kind of cool. So now I make sure we have supplements with magnesium and calcium.
Yeah.
And then I have my husband taking a little bit of extra magnesium because of his osteoarthritis and the pain he's in with the muscles. So, you know, it's just, I wish your GP could figure that out.
For sure. Well, thank you guys so much. This has been fun. I really hate to run, but I do have another presentation in 5 minutes. But please feel free to email me. We're always looking to connect with other teachers. And yeah, thank you for having me. This was a lot of fun.
Yeah, it was really good. It was really interesting. Now I
Thank
gotta think
you.
about where else can I bring things in? Start small and build out over time. It doesn't have to be all at one time. So
Right. That's the key thing, is don't feel like you got to do it all at once. You know, I think at least with teachers who care way too much, I think we feel like we need to do it all, right? But it's like, you know, find a way to
So
make it sustainable and workable. So
how are you going to get these slides?
we're going to post everything in the Google Drive. If you go to the conference website, there's a Google Drive, and as I get materials, we've been uploading them. So,
Thank you.
all righty.
all right.
All right. Thank you guys so much. Take care.
Thank you.
Bye-bye.
Bye. Thank you.
And technically, I mean, we can keep this meeting open a little bit longer. We do have a break after this, and we'll meet again at 11, depending on which session you're going to.
All right. Thanks.
So
Kristen, do we start back in the original Zoom meeting
that's
at 11?
That's what I'm looking at. Hold on. I've got too many windows open on my computer and I'm having just a hard time keeping track of it. So 2 of the meetings will be it depends on what you want to go to at 11:30 or I'm on the wrong day, at 11. There are 3 sessions at 11. If you're going to Sue Clemmer's session, it's in a separate Zoom link. The other 2 will be in the main Zoom link.
Okay.
So it's all about what you want to do. And then in the afternoon, if you want to go to the collision session, that'll be in the main Zoom link. If you're coming to my Desmos session, that's in a separate link. So.
And you're recording your Desmos one, right?
Yes.
Okay.
So that's all about, that's literally going to be all about creating, I'm going to stop recording.